Hello everyone, my name is Riya and in this video I'm going to explain the implementation of binary search tree. So in this program we'll be performing the following operations, that is insertion operation, search operation and the traversal operation, that is in order, pre-order and post-order. So let us see how to write the code for this program. First of all, we have included the header file, that is hash include iostream, and the standard library file, and we have defined a structure which I have named it as tree node over here, and the data member is data, int data, and we have two pointer variables of the type tree node, L child and R child, and I also have a structure member, that is root, which I have initialized as null, and I've also initialized both the pointers, that is L child and R child, as null. Now there's no need of declaring this one over here because we are directly defining it. So I'm defining a function, that is insert bst rec, and I'm passing two pointer variables, one is ptr and another one is new node. So this ptr is actually the root node. So inside this function we see that there's a if condition, that is new node pointing towards data is less than ptr pointing towards data, and inside this if statement there's another if in which there's a condition ptr of L child is equal to null. If it is so, then ptr pointing towards L child is equal to null new node. Else we are calling this function, there's a recursive call, insert bst rec, and we are passing two pointer variables, that is ptr pointing towards L child and new node. Else if ptr pointing towards L child equal to null, then we are making the ptr's L child equal to ptr's R child equal to new node. Else we are again calling this function, and we are passing two pointer variables, one is ptr pointing towards R child and another one is new node. Now let us see what is done in the insert function. In the insert function we are passing the value as a parameter, and we are creating a new node, and we are putting this value in the data field of this new node, and we are making the L child and R child of this new node as null. Basically the concept that we are using in this binary search tree is doubly linked list, and that is why there's two extra fields, that is one at the leftmost end and another one at the rightmost end, and we are making both the fields as null, and we are checking whether root is equal to null. If it is so, we are assigning the new node's value in the root, and else we are calling the insert bst rec, and we are passing two pointer variables, one is root and another one is new node. And for writing the code for the traversals, for in order, we know the traversal order is LDR. So first of all, the condition is checked whether if ptr equal to null. So if it is so, then we return. Else this function is recursively called, and we are passing the value, that is ptr pointing towards L child, and then we are printing the data, and again there's a recursive call, and we are passing ptr pointing towards R child. So this is following the traversal order, that is L, D and R. Similarly, for pre-order we know the traversal order is D, L, R, and for post-order traversal order is L, R, D. And for search we see that first of all we are passing two variables, one is key and another one is a pointer variable. So first of all, the condition is checked if ptr equal to null, so it will display that the tree is empty. Else if key equal to ptr of data, then it will show that the element is found and also true, and we will return. Else if we are checking if key is less than ptr of data, then we are searching, then we move on to the search function, in which we have passed the values, one is key and another one is ptr pointing towards L child. Else we'll again call the search function, in which we are passing key and PTR pointing towards our child. Then here inside the main function is a menu driven program, so that it would be easier for the user to understand the program. So in the case 1, we will be, if the user is entering 1, then insertion operation will be performed. If the user is entering 2, then all the 3 traversal orders would be displayed, and if the user is entering 3, then he or she will be able to perform the search operation. Now let's see how this program runs. So I've entered these elements, and these are the traversal orders, that is in order, pre-order and post-order. Now let me search any element. For example, I wanted to search 5. It is saying that the element is found and true. Suppose if I want to search 8, the data you wish to search, it is saying that the element is found and true. So this is how the binary search tree implementation is done. Thank you.